Hi everyone. In today's video, I will take up two questions in the topic of ship stability, and these two questions will focus on the effect of density on ship's draft and displacement. If you have access to Captain Subramaniam's Ship Stability Nutshell series book, then this is from book 1 or Ship Stability 1, exercise 5, and I'll be discussing question number 1 and 2 today. So let's understand the question. It's not only about solving the question but also understanding it so that your foundation becomes strong. So let's get into the question straight away. Question number 1. There is a ship that is floating in seawater at a draft of 8 meters. If her displacement is 16,000 tons and TPC, that is tons per centimeter immersion, is 20, find her draft in fresh water. So before you start solving the question, you have to understand what is happening in the question. So there is a ship, right, that is floating in seawater. It has a certain draft. In this case, it's 8 meters, of course. And from seawater, she's going into fresh water, right? So seawater density is 1.025 and freshwater density is 1. That means freshwater has lower density. Now, as the density of the water lowers, so there is a relationship between density and draft, right? So as the density lowers, the draft increases, and as the density increases, the draft lowers. So in this case, because the salt content is lowering, the density is lowering, the draft of the vessel should increase ideally. So the draft will become more than what it was when it goes from seawater to freshwater. You also have to remember that the displacement of the vessel doesn't change. Displacement is like the weight of the vessel. Just like your weight will not change if you go from freshwater to seawater. If you are 80 kilos, then you will remain 80 kilos no matter where you are standing. Similarly, the ship's displacement doesn't change. Only the ship either rises or sinks as the density changes. Now the relationship between seawater to freshwater and how much the vessel rises or sinks is known as freshwater allowance. Freshwater allowance determines by how much amount the vessel will either rise or sink if we are only studying seawater to freshwater. If we are not studying dock water. Dock water is dock water allowance. This is freshwater allowance. Now the formula for freshwater allowance is freshwater allowance equals to displacement of the vessel, that is the weight of the vessel, divided by 40 times TPC. Alright. Now remember, sometimes in some books they also say the formula is displacement divided by 4 TPC. That is also correct. Depends on the unit you take. So if you take 40 TPC, the unit will be in centimeters, and if you take 4 TPC, the unit will be in millimeters. But I don't want to confuse you here. I just thought I'll clear it in case if you are using some other book other than the one I am talking about. So displacement is 40 times TPC. So simply put the values now. It's only about putting the values. So we've got 16,000 tons as displacement. 40 by TPC is 20 given to you in the question. So here you have, what you have is 8 times 20 centimeters. So your unit will be in 20 centimeters. When I said if you take 40, the answer you get will be in centimeters. If you take 4, the answer you would have got was in millimeters. So 20 centimeters. Now because the draft here is in meters, we want the rise or sinkage also in meters. So how do I convert centimeters into meters? So 20 centimeters is equal to 20 divided by 100, which is equal to 0.2 of a meter. Now we have already determined if the density is decreasing. Here the density is decreasing, draft will be increasing, correct? So it will be increasing, so this will be like a rise of the vessel. Vessel will rise, correct? So original draft given to you in the question is 8 meters. Then you add the rise to it, and the new draft becomes 8.20 meters. This is the draft in fresh water. Right? I already done the second question to save you guys some time. That's why I had a limited space to work with. Now let's start with question number 2. Question number 2. I'll change the pen a little bit so that it is not too monotonous. This is question number 2. A ship goes from water of relative density 1.008 to seawater. Remember, there is no fresh water here. Now the density has become 1.008, which is called dock water density. Dock water, we can call it dock water. So we have seawater, fresh water, and then we have the rest of the densities are classified under dock water. You have to find the change in the draft of the vessel if her freshwater allowance is 180 millimeter. Now remember, in ship stability questions you have to keep a keen eye on the units as well, so otherwise you will get the wrong answer. You also have to state whether it will be sinkage or rise. Alright, so let's take up the similar understanding to what we understood before. So currently your vessel is in density of dock water density of 1.008, right, and you are floating at a certain draft. From here the vessel is to be going into density of seawater, which is 1.025. So here what is happening to density? Density is increasing. So what will happen to draft? Draft will decrease. So it has an inverse relationship. So draft has an inverse relationship with density, or vice versa. So you already know that vessel will be sinking. That means if draft is decreasing, that means vessel is going to be sinking. Draft will become lesser than what it was before. Correct? So we have to now determine, what do we have to determine? Find the change in the draft. We have to find the change in the draft, which is called the dock water allowance. So I explained to you before the relationship between seawater and freshwater and how the draft changes, as in question number 1, is explained through freshwater allowance. But the relationship between any other water of densities other than freshwater and seawater is dock water allowance. So let's understand how to apply this allowance here. Right? So the formula for dock water allowance, which explains the rise of the sinkage of the vessel with changing density of dock water to seawater or dock water to any other water of density, is nothing but difference in density. Right, this is difference in the density multiplied by freshwater allowance divided by, some books write 0.025 and some books write 1.025 minus 1, which is again 0.025. Depends on the kind of book you are consulting. Right? So we already know draft will be changing because the density is increasing, draft will be decreasing. We know that already, right? All we have to do is now find the change in the draft. So if we find the change in the draft, we know that the vessel will rise. It will move from lesser density to higher density. So vessel will rise. I hope I didn't say any other thing. So vessel will rise, of course. Okay, so density is increasing, draft will decrease, so vessel will have to rise. So water level will become lower. I hope I didn't say vessel will sink. Okay, so vessel will rise because the density will become lower. So here the vessel sunk. In the first case, vessel sunk more. You can see draft became more. Why? Because the density decreased. So draft became more in this case. The vessel sunk. So there was sinkage of vessel. All right. Here vessel will rise because density is increasing. All right. So difference in density. When we mean difference in density, we are talking about the density, the two density in question. So of course you always take the bigger number, which is 1.025 minus 1.008. Here we are talking about the two densities in question, density 1 and density 2. So always put the bigger number first. Don't want the dock water allowance to be a negative number, multiplied by freshwater allowance, which is given to you as 180 millimeter. So you will put 180 millimeter. Now remember, if you are putting millimeter, then the answer you will get is also going to be in millimeter. You will have to convert it to either centimeters or meter, depending on what you want to figure out. And then 1.025 minus 1 is 0.025. So put the values in the calculator, and what you will get is 122.4. millimeter. Now because I used millimeter here, I am going to get millimeter here. If I had converted 180 to centimeters and put a centimeter here, the answer I would have got was have been in centimeters. Now this is dock water allowance. So this is the amount by which the vessel will rise in this case. It will rise, making the draft lower. So depending on what you want to or what the examiner asks you, you can convert this into centimeters by dividing millimeters by 10, which will give you 12.24 centimeters. Alright, or you can also convert it into meters by, so you know 1 meter is equal to 100 centimeters. So if you got 12.24 centimeters, you can divide it by 100 and you will get 0.1224 meters. So depends on what the examiner asked you. If you want, you can keep it in millimeters, or you can convert it to centimeters or to meter. Alright, so I plan to take up some more questions in this topic because this topic often confuses students, and I'm going to solve the entire exercise from this book. Take up two questions at a time, probably 2 or 3 questions at a time, and hope it helps you with your understanding.